Hi students, today we have to discuss the chapter periodic classification of elements. Okay, periodic classification of elements. In this chapter we have to discuss about the classification of some elements. Classification of the elements. In the early time there were a lot of elements was discovered, and then studies about these elements are also done. At that time, the classification is not progressed. Then the scientist wants to classify these elements because the number of elements is increasing. They want to classify them in different groups based on their properties. So the scientist made several attempts to classify elements according to their properties to obtain orderly arrangement, to get an orderly arranged pattern. It needs to identify elements, and also it needs to study about these elements. Firstly, Johann Wolfgang Dobreiner started to classify these elements based on their properties. It was in 1870. He made a group of three. He called it as triads. That is why Dobreiner's triad. In 1870, Johann Wolf Dobreiner tried to arrange these elements with similar properties into group of three. He made these elements into group of three. For example, lithium, sodium, potassium. You can see the picture of triads here. He made three group of three. Okay, that is called triad. This is called Dobreiner's triad. What is Dobreiner's triad? The group of arrangements of elements with similar properties into group of three. That is Dobreiner's triad. Also, he found that when we arrange the adjacent elements in the form of triad, then the atomic mass of the middle element is the average of the atomic mass of the other two elements. Let us take it. It is an example for Dobreiner's triad. This is an example: lithium, sodium, potassium. The atomic masses also found 6.9, then 39, 23. He argued that the average of these two elements should be equal to, or the average of these two elements is almost same as that of the atomic mass of the central element. Let us take it. The average of these 6.9 and 39. This average 6.9 plus 39 divided by 2. How much it is? 6.9 plus 39. It is 45.9 by 2. 45.9 by 2. It is almost 46. Then the answer is 23. It's almost 23. That is the atomic mass of sodium. He made three pairs. That is the first classification, and it is the starting of periodic classification. Then we have to discuss about the limitations of Dobreiner. Dobreiner made triads, but some limitations. Dobreiner could identify only three elements from elements known at that time. Okay, three triads. Then so it failed. Then new classification is invented by Newland. He arranged elements in the increasing order of atomic masses. He arranged the elements in the increasing order of atomic masses. This masses is an important one. Okay, you have to notice these properties. At that time, only 56 elements were discovered. He found that every 8th element had similar properties of that of the first. This property is called law of octaves. He found that every 8th element had similar property. It is the first one, and the 8th one is fluorine. It is the similar to that of the first one. That is called law of octaves. So he made 7 group of elements, and the 8th element gives similar property of the first. It is the Newland's classification. Okay, we have to study these points. But in this classification, we can found some limitations we have to study. Okay, then limitations of Newland's theory. Law of octaves was applicable only up to calcium. The law of octaves, repeated properties, is visible only up to calcium. That is the first limitation of Newland's theory. And then Newland's argued that no more elements would be discovered. But a lot of element was discovered after this Newland's theory. Okay, it is false. Then he included more than one element in a single place. For example, cobalt and nickel placed in same slot. Okay, then some elements placed in wrong places. For example, fluorine, chlorine, bromine, and cobalt, nickel are placed together, but fluorine, and bromine have different property than that of the cobalt and nickel. Okay, the law of octaves only worked with light elements, smaller elements only. Okay. Then the third classification of elements is Mendeleev's periodic table. There was a lot of limitations for Newland's periodic table, Newland's law of octaves, and it is Mendeleev's periodic table. The main point is that he arranged the elements on the basis of their atomic mass. That is the difference. Okay, the first point is he arranged the elements on the basis of their atomic masses and also on the similarity of chemical properties. He not only the masses, but also he observed the chemical properties and included the elements they have same property in the same group. Okay. Then he started arrangements with 63 elements. There was 63 elements was discovered at that time. Okay. Then he also concentrated compounds formed by elements with oxygen and hydrogen. He also monitored a lot of experiments with the oxygen and hydrogen, how this element react with oxygen and how the other element react with hydrogen. He observed it and found the property. Then the elements having same property included in single group. Okay. He arranged 63 cards by writing the names of each element in each card. He arranged these 63 elements in logical way by writing 63 names on 63 cards. Okay. Then he found the property of the elements are periodic functions of their atomic masses. He found that after the arrangements, he found that the properties of these elements periodic in nature based on their atomic masses. When the atomic mass increases, the property repeating, that is periodic function. Okay, that is called the periodic law. Then the vertical columns he called it as group, and the horizontal rows he called it as periods. These are the main points of Mendeleev's atomic periodic table. You have to study it. Mendeleev's periodic table is different from Newland and Dobrynin's periodic table. It's a different one. It's related to our modern periodic table. There are a lot of connections. Okay, so achievements of Mendeleev's periodic table. He placed some elements before some other elements to achieve elements having same property in same group. He focused on the property. He arranged the elements having same property in a single group. He not obeyed the increasing order of atomic mass. For example, in the case of cobalt, 58.9 is the atomic mass. Is placed before the nickel. Atomic number is 58.7. 58.7 is the earliest one based on the atomic mass, but he placed cobalt firstly to achieve the same element in single group. Okay. Then he left gaps in periodic table. It helps to discover more elements. You can see Mendeleev's periodic table here. There was a lot of vacant places. It leads to discover more elements. Okay. For example, Eka-boron, he predicted some elements named Eka-boron. Is the element after boron. It was discovered scandium. Then Eka-aluminium is discovered as gallium. Eka-silicon is discovered as germanium. He also predicted the property of Eka-aluminium. His predictions is here, and the modern changes then after inventions is here. Atomic mass of Eka-aluminium is predicted as 68. It is 69.5. Then formula of oxide E2O3, the same, gallium 2O3. Then formula of chloride ECl3, the same thing repeated, gallium Cl3 is invented. So his predictions leads to several achievements, and it leads to the modern periodic table. Okay, then limitations of Mendeleev's periodic table. He could not assign the correct position of hydrogen in his table. The hydrogen is just placed above that first group, but it is not the correct position. He just placed on the above of that group. It is not the actual position. He could not assign a correct position to hydrogen in his periodic table. And the second limitation is isotopes of all elements posed a challenge in Mendeleev's periodic table. There was no idea about isotopes. Then he arranged the elements based on their atomic masses. He arranged all elements based on the atomic masses. Atomic masses do not increase in a regular manner. So it was not possible to predict how many elements could be discovered between two elements. It is not possible. So the modern periodic table is arranged based on the atomic number, but Mendeleev arranged based on the atomic masses. That is the limitation.